Good morning, everyone, from whichever part of the world you are joining this webinar. Thank you for registering to our webinar and taking time to attend this session. We are very much excited to showcase our ED137 and ED138 test solutions in this webinar. This webinar will be presented by two of our senior product managers, Srinivas and Nagaraj from our Bangalore office. First of all, we wish to thank you for visiting our booth in the recently concluded Airspace Expo in Hong Kong. I think most of you are well versed with the GL, but for those who are not familiar, let me give a brief overview about our company. We are a 35-year-old company headquartered in Maryland. We have an offshore development and support center in Bangalore, India, and we have another office in Shanghai, China. We also have several representative offices all across the globe. So you can reach out to us through any of these representatives, or you can directly reach out to us for any of your test requirements. We have many years of experience in the telecommunication industry, providing consulting services and comprehensive suite of test solutions to verify network performance in various telecom networks, including wireless, fiber optic, and traditional landline networks. We work with many of the major telecom equipment vendors, service providers, defense contractors, system integrators to meet their testing requirements arising at various stages of the product development lifecycle. Our core strength lies in core protocol analysis and emulation across various networks. These products can interface to all telecom networks, including wireless, fiber optic, and legacy networks. These products can both monitor existing traffic flows as well as generate customizable traffic. Voice, video, and data can be monitored, captured, stored, analyzed, replayed, and emulated as the customer requires. And with regard to the air traffic management solutions, we have sold our products to many of the air navigation systems solution providers, and it's been used by several of these ANSPs all across the globe. With this brief introduction, let me hand over to my colleague Srinivas, who will dive into the key technology and other aspects of today's webinar.
Thank you, Sanju. Hello, everybody. Good morning or good afternoon. Yeah, so before going into explaining our solutions, let me go through the ATM migration challenges that the industry is going to face or it is facing already. Okay. Basically, here we need, since during the legacy period, every country has its own standard, or the zone has its own standard kind of thing. Okay. Now the standards have been globalized. Okay. And those are defined by the EUROCAE, and specifically these are ED137 and ED138 standards. Okay. So making sure all the new equipments are in compliance with these ED137 and ED138 standards is a must requirement. Okay. And for this, we need the compliance testing or the deep down testing of the equipments. Okay. The second one is interoperability with legacy systems. So as you know, the whole entire system or the infrastructure cannot be migrated in a overnight or something like that. Okay. So there are going to be still few of the elements are going to be a legacy systems and few will be supporting the VoIP. So there has to be an interoperability between the legacy systems and the upcoming IP based systems. Next one is the ANSPs, since they are redoing this entire infrastructure, trying to bring the IP wherever it is possible. It is very much necessary that they have to do all kinds of rigorous testing, like for the reliability, stability, robustness, high availability, redundancy, and performance, and so on. So before they commission the network or the equipment, it is very much required to do all these detailed testing so that everything is in safe. And unlike circuit switch network, these IP network will introduce the latency, jitter, and packet loss, okay, which can lead to the degradation of the voice quality, okay, and there could be a delay in the signaling and all, okay. So that requires a 24/7 monitoring and troubleshooting of the network, okay. The next one is we have to make sure that all the end-to-end signaling delays on the voice delays and also the voice quality across these networks when it goes from legacy to IP or IP to legacy, those kind of things. We have to make sure that all the delays are within the acceptable ranges and the voice quality is excellent enough, as this voice communication is very critical for the safety of the flyers. Okay. Performing deployment, commissioning, and field testing are also the challenges because we are replacing the equipments, bringing the new equipment. So we need to do all these kind of testing. Okay, keeping these things as a requirement. Okay, GL has developed keeping all these things as a challenge. Okay, which the industry is going to face. We have come up with a suite of test equipments. Basically, we have three categories of solutions. First one is the ED137 emulators, wherein we have a radio emulator, which will be simulating the air to ground calls, either by simulating the controller working positions or the ground radio stations. And next one is the telephone emulator, which will be simulating the ground to ground calls by simulating the multiple controller working positions. And then we have a recorder, which can simulate either the recording client or the recording server to record all the communication and create that kind of traffic and all. Okay, so basically these emulators are used to perform the end equipments functionality testing, deep down testing, negative testing, and all kinds of compliance testing can be done before the product or the device is commissioned for deployment and all. Okay. And the next category is ED138 monitoring solutions. Okay. So ED138 standard defines what are the accepted criteria for the network requirement. Okay. So to measure these things, we have a product called a packet scan, which can non-intrusively capture all the traffic in the network and segregate them into air to ground and ground to ground calls. Then it can perform a very detailed collect detailed statistics on the call, both on the signaling front and the voice quality front. And it can optionally create these call detail records, okay, which can be pushed to a centralized database. And we have another product called a Net Surveyor Web. Okay, it's a web-based application which works in tandem with the packet scan. Okay, and it actually pulls the records stored in the database and presents them in a very systematic way, providing a lot of call detail records, providing all the graphical reports for both real-time and historical analysis. And since it's a web application, it supports multiple users. Okay, so that multiple users can monitor how the networks, how the calls are happening. What is the quality of the calls? They can compare with the previous historical data with the current data. They can look out for the trends and all. Okay, so that kind of a complete analysis can be done with these ED138 monitoring solutions. Okay, so basically there we provide the voice qualities like MOS, packet loss, jitter, all those things. Okay. Then the third category of solutions is critical delay and voice quality measurement. This is a kind of an intrusive test where we'll be simulating the end nodes. And for example, assume that there is a VCS and a radio is deployed, and you want to measure the delay from controller working position to the radio, how much the PTT signal takes and how much the voice delay, one-way voice delay is there, and whether the quality of the voice is good enough at the radio when it is received. Okay, to perform those kind of measurements, we have this suite of equipments which can actually connect to the existing devices, and they can simulate the PTT, squelch, and the inject sample voice files, voice, and that can be recorded at the other end, and simultaneously we can measure all the signaling uh, delays. Okay, so that will make sure that after deployment, like before the deployment, all the delays and qualities have been made sure that it is all within the expected ranges. So with the summarization of the entire solutions, whatever we have, now I'll quickly jump on to the individual products. Okay. So let me begin with the emulators first. All our emulators use a framework called MAPS. MAPS stands for Message Automation and Protocol Simulation. Okay, so basically this framework provides provides to simulate multiple hundreds of controller working positions or the ground radio systems, and it also allows us to generate multiple calls. Even the bulk calls, like hundreds of calls, can be run for the infinite time, so that you can load your network and see the maximum capability of the network. You can even simulate the scenarios like the peak busy minute and peak busy hour, and see how the equipments and the network behaves during this peak traffics. Okay. So apart from this, as the name says, it also allows us to edit the messages or the create our own protocol state machines, so that any kind of test can be created. And it also allows to have negative scenarios by applying the invalid values, or by creating a invalid call scenarios. So all kind of positive and negative tests can be performed on the equipment. So let's begin with the radio emulator. Basically, radio emulator is a software application. Okay, it actually emulates the air to ground calls as per EUROCAE standard CD137 volume 1 radio. Okay, since it is a software only, like it can be installed on any Windows operating system machine. Okay, it has a very easy to use graphical user interface, and optionally we provide the Python APIs also for integration into third-party solutions and all. Okay. So let us see some of the important features of this radio emulator. As I told, it can emulate the controller working positions or the ground radio stations as per ED137B and C standards. It supports both of them. Okay. And it can emulate multiple controller working positions or the ground radio stations by using the unique IP addresses, okay, in a single system with a single license. Okay, since the product is just a software, okay, it's a very portable application. You can just install on a laptop and take it for all kinds of testing, like field testing, and move around your premises or the labs. Okay, it is very easy to configure since it has a very user-friendly graphical interface. You can quickly make the calls, and you can edit any kind of parameters, and do all kinds of deep down testings. Okay. Yeah, it supports all the radio call types, PTTs, all the SIP headers and STP attributes can be edited and changed. Okay. It also supports the advanced features like link session management, WG67 key in event, multicast routing, and selective call tone transmissions. These are the features that were introduced in the C version. Okay. And yeah, apart from that, it also supports both IPv4 and IPv6 addressing. And this emulator is also validated against latest voter versions 4.1.33.1 and 33.2. So next on this screen, as I told, we can simulate multiple working positions. You can see that there are 10 controller working positions have been configured here. When you click on the particular CWP, this panel displays the middle panel displays all the parameters and the current values. Okay, and by selecting a particular value, you can change the value on the right side. Either you can select a drop down value, or you can enter your own values also. So when you say parameters, you can see that all the call parameters which are related for SIP signaling, okay, You can select the transport type, whether it is IPv4 or a V6, UDP or the TCP transports. And then we have some RTP parameters like RTP IP address ports. And then we have a huge list of ED137 parameters as defined in the ED137 specifications, where you can configure each of these parameters. Okay, as I told, either you can select a drop down or you can even configure your own custom values. Okay. So that is the beauty of this application. Okay, so it gives complete flexibility in editing and like creating your own scenarios or the messages. Okay. Yeah, it also supports some of the advanced header extensions of the RTP, which are used for specific purposes in this radio communication. These include like a climax time delay, where we can apply the delay to the transmitters to how much to delay the transmission. Signal quality index that measures the quality of the squelch. Okay. Radio remote control, which will allow you to control the main to standby F1, F2, TXRX switching of the radios. Dynamic delay compensation that will allow you to measure the delay to the transmitters and the receivers that are connected dynamically. Okay. And with respect to traffic actions, we can send and record the audio files, send and detect the digits and tones, or we can talk using the microphone, and we can even play the incoming voice to the speaker. Okay. And we can also apply some impairments such as packet loss, duplicate, out of sequence, and latency, which can be applied to the RTP traffic that is being generated. So this feature will help to create those impairments well in advance and see how the equipments or the network behaves, and you can come up with a plan to how to mitigate these things. Okay. Or how to overcome these kind of things when in certain conditions if they occur in the network. And next one is the codecs, audio codecs. We support A-Law, U-Law, and Z729. And we also provide some of the automated test scripts which can perform the automated actions like PTT and squelch. So without manually operating the PTTs and squelch, you can randomly simulate these PTT and squelch on and call. These are for the performance test and consistency for verifying the consistency of the equipment. So next one on this screen, we are showing a call reception window at the ground radio station. Okay. So you can see that multiple radios have been created, and these are the controller working positions that have been connected, and we are using some color code to group the calls and visually mark them like what radio they are established. And you can see also the zip call control.gls is the base script which simulates the entire A to ground state machine. Okay. And then we have a start and stop that is to control the initiate a call or stop the call, radio call. And then we have the status which will keep updating as and when the call progresses. And there are some PTT buttons, squelch buttons. And then we have the result column which will indicate whether the test has passed or a failed kind of thing. So these criteria can be defined by the user in the script itself. Okay. And we have a few of the function buttons specifically. For example, if I want to apply the impairments, or if I want to play the incoming voice to the speaker, or if I want to create a scenario where I want to stop transmitting both RTP and R2S to see whether the call sustains or gets dropped. Okay. And apart from that, the most important thing is when you select a particular call, okay, it gives the complete call sequence for that call, including both signaling parameters and all the radio activity events that are happening. So as you can see here, there is a PTT on, emergency PTT feed, and it is turning off along with the timestamps that when they have occurred. Okay. And when you click on the particular messages, okay, on the right side, we provide the complete message decodes, okay, that will indicate what parameters have been negotiated, or the, say, for example, if a call fails, then you can come back and look into this one. A good example is like if the frequency ID or the call type is not matching, then you can come down here and check like what value we have sent and what value has been received from the opposite end. So this gives a very good feature to quickly check the functionalities of the equipment and all, and find out the reasons for the failure and all. Okay. And apart from that, we support all the call preemption, PTT priority handling and all. We also simulate both separated and combined GRS scenarios, radio scenarios. And apart from that, we can simulate hundreds of calls simultaneously. That is the bulk call scenario, where we can pump hundreds of calls or receive hundreds of calls and perform some automated traffic actions on that one. And we can also detect pilot to pilot and controller pilot induced SCTs. Okay. So this is the screen where we are showing we can simulate multiple controller working positions and the multiple ground radio stations with a single instance of application. So the next one is a telephone emulator. Since it uses the MAPS framework, so all the features like are same with respect to the graphical user interface or the Python interfaces and all. Okay. Okay, let's see the some important features of the telephone emulator. So basically, it emulates the controller working positions as per ED 132B or the 2C standards. It supports both. The license is not separate. Single license supports both this one. And then we have like we can create multiple controller working positions. And again, we support ELA, ULO, and G729. Apart from the basic telephone features, the specification is defined for some of the addendums. For example, addendum 2 is for FAA legacy telephone networking. Addendum 4 is to simulate the override calls. Addendum 5 is for simulating the voice calls. Okay, we support these addendums also as an optional software. Okay. Again, telephone also supports both IPv4 and IPv6, and it is validated using the latest version of the voter. So similar to the radio, like here we have a list of controller working positions and a similar set of parameters. Only thing is under ED 137, instead of radio parameters, we'll be having the telephone parameters that are required for ground-to-ground simulation. Okay. And apart from that, we do support all types of ground-to-ground calls like IA call, DA call, monitor call, and there are specific call scenarios like call hold, call transfer, pickup, and call intrusion. These features are all supported. And one important thing is, we can forcefully emulate all the SIP error messages on the call. For example, these are not something that you can naturally create those scenarios. Okay. So it is important that when these error messages are received on the equipment, for example, at the controller position or the VCS, how the VCS is going to handle. Does it handle as per the SIP standards or not? Okay, so to simulate those things, we can forcefully send these errors on the call. Okay. And again, here also the same traffic actions and impairments can be performed. Okay, as you can see here, this is a call generation window. Again, this is the same SIP call control.gls, which can simulate all the ground-to-ground scenarios. And there are some scripts which are designed for specific scenarios. For example, call intrusion or a call pickup scenario. So all are available as a drop-down here. Okay. And here we can we can configure multiple calls here, and we can use multiple controller working positions, and all these tests can be run either sequentially or it can be run simultaneously, and it can even be run randomly also. Whenever we are running them one by one, we can also opt like how many iterations we want to repeat these calls and all. Okay, all these features will help in performing like automated tests. Like you have a group of test cases, you just want to simulate them one after the other or something like that, and for a certain number of iterations. Okay, so as and when you progress, it will show how many iterations have been completed also. And again, we provide the call graphs and the message decodes for each of the call. Okay. And yeah, apart from this, again, we can simulate hundreds of ground-to-ground calls simultaneously with some kind of automated traffic on that one. And we can also simulate like multiple controller working positions. So this is a picture to show that multiple controller working positions have been simulated, and they are simulating all kinds of the ground-to-ground calls like DA, DIA calls and all. Okay. So the next one is the recorder emulator. Basically, this recorder emulator, again, it is also it also uses the same maps framework, and it has all those common features whatever we discussed earlier. So as a recorder emulator, it can either simulate the recording client or the recording servers. Okay, multiple client and servers can be simulated, and this is as per the ED137 volume 4 recorder interface. Again, we support both B and C versions. When we are simulating the recorder client, we can either act as a recording client at the controller working position or at the ground radio station and create all these recording sessions. Okay, so here we are not actually simulating a CWP to a to ground call between CWP to the GRS or a CWP to another CWP. We directly simulate the recording sessions and simulate all the traffic that is seen on an actual A to ground call. For example, a PTT, squelch, or call hold scenarios or call forward scenarios in case of ground to ground call. Okay. This product also supports both IPv4, v6, and it is also validated using the OTR. And one important feature here is the specification defines 3 types of audio transmission. One is using an independent UDP or an independent TCP, or we can also do an embedded binary data. It is like audio is sent on the RTSP session also. Okay, so basically here RTSP session protocol is used for establishing the recording sessions with the server or the client. So here we are giving some scenarios. Okay, basically, as you can see here, we are acting as the recording clients at the CWP or at the CRS, and we are creating this recording session towards the recorder, which is the device under test. Okay, by this way you can create the you can test your recorder with multiple by simulating multiple controller working positions or the ground radio stations. You don't need to actually have a CWP or the GRS or the VCS, so many equipments. So you can just hundreds of clients can be created and traffic can be simulated. Similarly, this is for the ground to ground calls, where it is going to simulate the ground to ground scenarios towards the recorder, basically recording the ground to ground calls on the recorder. Yeah, here we are actually acting as a recording server. For example, if you are a CWP or the VCS manufacturers or the radio manufacturers, so you need some recorder application to test your recording interface that is implemented at the VCS or the radio. Okay, so by this way we accommodate the other side of the testing. So similarly, we can create these recording client server or the recorder profiles here, and we have a similar set of parameters, but here instead of SIP, RTSP protocol is used for the signaling to establish the sessions, recording sessions, and RTP is used again for the media. And there are a huge number of ED137 parameters which can be configured so that they'll be used when it is building the call detail records and all. So those parameters are included in the RTSP control messages. Okay. So again, we can have multiple recording sessions. We can, when we are acting as a recorder, we'll record all the incoming information as a call detail records to the CSV file. And we also automatically record the incoming voice and save it as a pre-recorded voice files. So as you can see, here also we are providing the message sequence and all the message decodes that will tell like these are the parameters which have been configured in the previous stage. Okay, so this tells about the calls property, like who is the caller, callee, what is the call priority, call initiation time, and other things. Okay, so all these informations can be customized, and you can create your own call detail records also, like the property or the operations you can create. Okay. Some of the key updates on this, all these three emulators, all the three emulators support both B and a C version with a single license. Okay. They all support the IPv4 and v6. They are all validated against the voter. And one of the few of the important things we have attended, we are also a member of EUROCAE group. Okay, we do participate in all the working group meetings and discussions, technical discussions. And in the past, we have participated in the FA VoIP interoperability event back in 2019. Okay, where all our emulators, packet scan, and net survey web equipments were used by multiple vendors for performing the compliance test suits. Okay, so EUROCAE is also planning for some upcoming IPv6 plug test where it is exclusively use IPv6 as the transporter. So addressing, so we plan to participate in that one. So basically we are trying to explain here like how closely we are with the EUROCAE and following the industry developments and everything to keep us up to date. And we have been adapting all the additional changes that are released by EUROCAE. We automatically bring in and adapt those features and provide the new releases of the emulators. So that concludes the emulator part, and then I will quickly go over the monitoring solutions. Okay. On the monitoring solutions, as I told, we have two products. One is packet scan that does the main job of capturing the traffic and segregating them and collecting all the statistics and building the call detail records. Once it builds the call detail records, it will push it to a net central database, and that can be picked by this net server web application. Okay. So as you can see here, we have connected to a mirror port of the switch, and we are seeing all this traffic that is going through this WAN or the LAN. And then we are using the packet scan to capture. Okay, packet scan can act as a probe, so it can be deployed at multiple locations also, or it can be connected at the centralized location. So from wherever it is, it will push all the call detail records it has collected to a central database, and then using the web application, we can hook to that database and pull out the records and display all the records here. So let's look into the features of the packet scan. This is the main window where we have captured so many packets here. Those will indicate the frame summary, like what SIP, whether they are SIP packet or RTP packet, and what are the IP ports and other SIP application protocol specific information. And below we are providing the complete decode of the RTP packet that also decodes the complete ED137 headers. So we even decode all the header specific extensions also and provide the complete decode of the messages. Okay, this will help in analyzing like what parameters have been exchanged and all. Okay. So using packet scan, we can capture it for an infinite duration, and we can save these traces periodically so that we have all these records and all. And as I told, this acts as a probe and can be deployed on multiple locations. So wherever it is connected, so it will collect those packets and derive the statistics from that probing location and send it to a centralized database. So when I say that statistics, that those statistics include all the signaling statistics like who is the caller, callee, call status, those kind of things. And on the voice quality front, we provide the how many packets have been received, dropped, duplicate, out of sequence, and most importantly, the voice quality using the MOS scores and yeah, the R factors. Okay, and these MOS score and R factors are calculated per session also. Okay, so this is the call summary view. The previous one you saw was the frame summary. So here you can see the calls are identified and listed here. The line in maroon color indicates the call details, and the two black color indicates the traffic directions, the PTT and the squelch, you can say. As you can see here, some of the calls have a very bad MOS scores, which is like a 2.2 or something like that. A good MOS score is considered anything above 4. Okay, and for the bad quality, you can see like what is the reason here. So that it has some missing frames, which has led to the degradation of the voice quality. Okay, so here we can save the individual traces to the uh, calls to the traces, or we can record the audio, we can playback the audio, we can perform all kind of features like detecting the digits and tones transmitted on the call. Okay, and we provide again the complete call graph and message decodes for the detailed analysis. So this is an animated this one to show like there is a low MOS score and the reason is missing packets here. That's why it is graded as a bad call. And on a good call, you can see that we have achieved a perfect 4.20, which is the maximum score for a U law or a A law. Okay, this is indicated as a good call. Okay, and as I told, for every PTT and a squelch, we calculate the MOS and voice quality statistics separately. Okay, so it is not an average value for the call. So every PTT and squelch has its own values, and it is provided. In case of ground-to-ground call, we divide the duration of the call into multiple time slots, like 10 seconds or 20 seconds. So we can measure it separately, so that we are getting a very granular result of the voice quality. So the other product is a Net Surveyor Web. Basically, it's a web-based application which can actually hook to the database, and to that database, multiple probes may be feeding the data. So, and it is very useful for the ANSPs to monitor the entire health of their network by deploying multiple packet scan probes in different locations. Okay, and gather all the information in a centralized database, and use the web application as it provides supports multiple users. So each user can log in and check on a specific zone also. For example, based upon the probe also, you can filter and see only those records. Yeah, as you can see here, these are the call detail records for each of the call, and we are providing some quick CDRs also to see only the air to ground calls or the ground to ground calls, or some good examples. Or if you want to see the failed calls, you can just click on this one. It will list out if there are any failed calls, the poor quality calls based upon the MOS scores and all. Okay, and we have a lot of filtering mechanism, either based upon the date, time, or navigation into the pages, and we provide a huge list of filters. You can look for a specific call from a particular CWP or the GRS. Okay, those are the features it supports. Yeah, so when you go to a particular details of the call, this is what we get. Again, we get the complete call graph, message decodes, and a huge list of event summary to provide the full picture of the call. And these call details can be exported to a PDF file or a HTML file. As I told, we provide the graphical reports here with both historical and real-time data. So these graphs, as you can see, failure calls with a different failure causes, and some packet loss and the MOS scores and all. So this gives a complete picture about how the call quality has been varying over a period. And apart from this, the product also provides the filtering and capability, and it can also send an automatic email notifications to the user, indicating that certain calls have been failed or certain calls have achieved a low MOS score, so that he can get the details like the trace files or something and analyze it later. Okay. So that concludes the emulator and monitoring parts. Now my colleague Nagaraj will take you over on the delay and the voice quality measurements in ATM. Thank you.
Hello everyone. I will be introducing you all to GL's critical time delay and voice quality measurement solutions. As per ED138 performance matrices, there are certain delay and voice quality requirements defined, which must be met by the air traffic management network or by the devices integrated into the ATM network. So delay and voice quality are especially important with transition to IP networks, which introduce packetization delays, jitter buffer delays, and other uncertainties. GL's critical time delay and voice quality measurement solution is a test suite of equipment designed by GL Communications to emulate endpoints, probe events of interest, calculate signaling delays, measure voice delays, assess voice quality across devices such as VCSs, gateways, radios, and other elements in the network. It includes end-to-end measurements as well. On the screen, you are seeing a typical air traffic management network, which includes different elements comprising both legacy and VoIP devices. For example, in an essential scenario like measuring a push-to-talk delay between controller working position and the VoIP network, here are the different timing points for a signal or voice event at various probing points in the network. Using GL's test suite, we should be able to calculate delay across devices, delays across the network as well. On the screen, we can see timing references such as T0, T1, T2, and so on. These indicate the timing of an event at different points in the network. For example, T0 is a push-to-talk event that occurred at an analog endpoint far left-hand side at the legacy VCS. Another reference is T2, which is push-to-talk event detected on the VoIP line. This event identified and extracted through ED137 headers on the VoIP traffic. This slide lists some of the important events for which delay calculation is critical in ATM network. These events include PTT, PTT confirmations, squelch events, end-to-end voice delays, transfer delays, main to standby transfer delays, mute and unmute like events, etc. Now, this particular slide shows how our test suite of equipment is integrated into air traffic management network to simulate analog endpoints, to simulate VoIP endpoints, to probe and precisely timestamp events at different points in the network. On the far left, we can see that the audio analyzer, which is capable of simulating push to talk and inserting voice at the VCS at the analog interface. Next, the packet analyzer sits in line between the VoIP endpoints. It has ability to filter the traffic, precisely timestamp the events at the line rate, probe and timestamp events with a nanosecond precision. Our probing devices support synchronization using the GPS if the probing points are geographically apart. If they are within the lab environment, devices also support daisy chaining for the time synchronization between the different probing points. We have event data logger, which is centralized device that collects all the events filtered and forwarded from the different probing points. We also have another application called Maps Administrator, okay, which is a GUI based client that orchestrates the entire test scenario from emulation to probing. It stores timestamped events and in turn calculates delay between those events, calculates statistics, generate test reports, etc. And GL meets all the critical specifications for ATM and voice quality measurements. GL meets all the critical like specifications for ATM delay and voice quality measurements for VoIP, analog, 2-wire and 4-wire legacy interfaces. Now moving on to the voice quality measurement in air traffic management networks. This slide illustrates how voice quality is measured across the ATM network. Essentially, voice quality measurement involves analyzing the audio as it travels from one point in the network to the another. In this scenario, we transmit audio from one end of the network, for example, from the controller working position, and capture the audio at the other end. The captured audio is then compared against the original transmitted reference file using standardized voice quality algorithms. GL supports two industry standard algorithms. One is PESC and another one is Polka. PESC is based on ITUT recommendations P.862 and Polka is based on ITUT recommendations P.863. Both algorithms generate MOS score ranging from 1 to 5, where 5 represents the best perceived audio quality. This allows us to objectively assess the quality of the voice as it traverses the entire network path. The test audio files are typically short, around 6 seconds, and we use variety of samples including male and female voice samples, as well as different languages to cover wide range of frequency responses and realistic operating conditions. This approach provides a very good indication of the actual voice quality experienced by the end users. In practice, these tests are usually run over an extended period of time to observe how voice quality behaves. For example, under different traffic load conditions, at different times of the day, or during varying network conditions. Running voice quality measurement over a time helps identify degradations or trends that may not be visible in the short duration tests. Now in this slide, we will look at how test suite of equipment developed by GL will be typically deployed. In most cases, this solution is deployed using standard 1U rack mounted systems. As shown in the slide, we have central rack which hosts Maps Administrator, the voice quality measurement software, Net Surveyor Web, and other centralized control and analysis applications. The central system acts as a controller for entire test setup. In addition to the central rack, we do have a separate racks for packet analyzer with a dedicated hardware, audio analyzer with associated hardware, discrete signal logger also is a hardware based solution. Depending on the size and complexity of the network under test, multiple racks for each type may be required. These racks can be stacked together, interconnected, and fully integrated into the system. All the components are centrally controlled and orchestrated through the Maps Administrator, providing a unified and synchronized testing environment. In addition to rack-based deployments, we also offer the solution as a portable deployment option. In this case, we use compact probe units, which are small form factor devices that include GL's specialized hardware along with the embedded PC. So these portable probes are ideal for scenario where mobility is required. They can be easily transported to different sites, deployed for quick testing, and then brought back once the testing is complete. Functionally, everything that can be done using rack-based system can also be achieved using these portable systems. The choice between rack-mounted and portable deployment depends on the testing environment and operational requirements. Both options provide same comprehensive capabilities for delay measurement, event probing, and voice quality analysis across air traffic management network. So this concludes the presentation. Over to you, Sanjeev. Thank you.
Yeah. Thank you, Nagaraj. Thank you, Srinivas.
Thank you once again for everyone for attending this webinar. You can always contact us by filling up the info request form, or you can send an email to us at info@dl.com. We'll be more than happy to answer your questions. Thank you once again.